bottom. All right, we are talking about developing the 4 C's in mathematics. I put the link to the slides in the chat if you would like to have a copy. And I may be having just this much too much fun using Canva. So I made a little video of myself making faces, and then I screen grabbed them and added them into Canva. So let's see how this goes. Okay. Whoops. I got rid of the film strip on here just so I could see what that would look like, but I don't like that. Okay, I guess that was somebody's idea. That one was not my idea. Many things are my idea. That was not one of them. Try that. All right, so how to develop the 4 C's in math. When the reality is that most, what the heck kind of word is that? Most worksheet math problems have 0 C's. That's right, it has 0 of them. And not only do you want some C's, you would like to also have at least one mathematical practice. And again, most of them have none. So that would be the problem with traditional math problems. They have no C's and no mathematical practices. And a digital worksheet is still a worksheet. So when we talk about the 4 C's, we're not talking about digital or computers or Jamboard or Desmos or anything else. Many of the digital math things you see also have 0 C's and 0 mathematical practices. Now, digital is different, but paper is different also. It is not 2021. It is 2021. It is not 1921. We should do things differently with paper or digital, but just ask a different question. We want to have at least 1 C. Have at least 1 C, so we want to either communicate ideas or collaborate or creative thinking or critical thinking. One of these, preferably all 4. All 4 would be great, but at least one of these should be present in almost all activities. So let's say 90% of the time. Hey, Kristen, welcome. I'm going to back this up just a little bit for you. How to develop the 4 C's in math. That most, I did it again. Most math, I made up a word. Most worksheet math problems have 0 C's. Thank you for that. They mostly have 0 mathematical practices when they should have at least 1. And a digital worksheet is still a worksheet, and paper is different, just along with digital is different, that we want to be 2020, not 1920. So when we look at the 4 C's, it is communicate ideas, it is collaborate, it is creative thinking, and it is critical thinking. And you have at least one of those, if not more than one. And I would like to emphasize that none of those is show your work. And none of the 8 mathematical practices is show your work. So that's why I am anti-show your work, because I'm pro 4 C's, I'm pro 8 mathematical practices, I'm anti-show your work. Okay. So 2 trains leave the station at 4 o'clock. One goes east at 30 miles per hour. The other goes west at 50 miles per hour. How long until they are 90 miles apart? Which C is this? I'll back up. Communicate ideas, collaborate, creative thinking, critical thinking. 2 trains leave the station. Which C is this? There's a reason my note cards are blank. And my note cards are blank because the answer is none of them. None of them. This is none of the 4 C's. We're not asking students to communicate any ideas. We're asking them to fill in an algorithm. If you are giving students the algorithm, they know the algorithm, they've been told the algorithm, they do not remember the algorithm, but they should know it. They are not critical thinking. They are not communicating ideas by showing their work. Show your work would be to explain something along the lines of, show their thinking. It would be along the lines of, okay, we're 90 miles apart, so it's a total of 90 miles, and each hour, the first train is going 30 miles, and each hour, the second train is going 50. And since they're going in opposite directions, I would say that in 1 hour, they would get 80 miles apart, but this is more than 80 miles, so it has to be a little bit more than an hour. So that's where I reasoned through it as opposed to just worked it out. Big difference. So I want them to reason through it. I want them to explain the rationale. How does I don't even need the formula. What if I've never given students the formula and I want them to, how do you think you would figure this out? Approximately, what can you estimate it before you even tackle the question? That we ask them to approach it with some number sense rather than just filling in the algorithm. Oh, wait, I was backing it up. All right, do they collaborate? Do they collaborate on doing this problem? No, not at all. I saw your question, Gabby. Is it creative? It's not creative to fill in an algorithm. Trying to remember what algorithm to use, not creative thinking. Something I would like to never, ever, ever hear again is, but that's not how my teacher does it. Yeah, no, the way your teacher does it is not creative thinking. That's how your teacher does it. How would you do it? That's not necessarily the same thing. And so creative thinking allows for students to do it in different approaches. And critical thinking would be more than DOK1. Now, this problem is hard. And if I were to ask people, what DOK level is this? I bet I'd get a lot of DOK4. But the truth is it's DOK1. If I've given you the formula, D equals RT, distance equals rate times time. If I've given you the formula that D1 plus D2 equals the total time, or the total distance rather, then I've done all the thinking for you. I've given you the formula. I want you to apply the formula. This is DOK1. Unless they figure out the formula, this is not a critical thinking question. So we oftentimes mistake hard for complex, but this is actually not a complex question. It's DOK1. So which C is this? None of them. Which of the 8 mathematical practices is it? None of them. So instead, we'd like to look at low floor, high ceiling questions. Low floor, high ceiling questions. But before I do that, Gabby had a question about this question, and I'm going to read it. She said that would be critical thinking and communicate at the same time. Gabby, I think it is difficult to demonstrate critical thinking without communicating. So often you do both.
I was asking that because you said that maybe we could ask the students to say, um, describe how they think.
Yes.
And then he would be communicating ideas and
Yes.
also his thinking, how they think.
Yes, absolutely. If I start this with, here's the question, how do you think we would do it? I don't know. Okay, that's fair. I don't know. A good question should really start with, I don't know. Right? When I ask them, I should expect I don't know. Not I should, if I expect they know how to do it, it's DOK1. Right there. If you expect they'll be able to do it, it's DOK1. All right, DOK3, I should expect and I don't know, or a horribly bad guess. Okay. All right. I see. I don't know. All right. Well, what's going on in here? Let's make some observations. So when I do math problems with my students, and trust me, this drives them nuts because I have 11th graders and 12th graders who are not used to being asked to think about their math problems. They're used to being asked to crank out their math problems. I'm like, well, what do you notice? I don't know. No, just anything. What do you notice? 50 miles an hour. Okay, 50 miles an hour. And I write that down. And that's a lot of times what I'm using Jamboard for, is I try to poker face and not give them any indication I like or do not like whatever it is that they said. But rather, I want them to just Even if they're ticked off, whatever, Keeler, it's 90 miles apart. Okay, 90 miles apart. What else? 4 o'clock? Super, 4 o'clock. And basically, I just write down one little tiny piece at a time, every single part of this math problem. Okay, well, what do you think it means to go east? Can you draw me a picture of this? Because math is creative and visual, so let's visualize it. We're going east, okay? You don't know what east is. Pick a direction, okay? We're just going to draw this plus sign, north, south, east, west. Okay, he's going east. So what does it mean that the other person's going west? What does it mean? This guy's going east. This guy's going west. What does it mean he's going west?
The opposite.
Hopefully. What is it?
No, the opposite way.
Yes. That someone will say the opposite way. I'm not going to assume they know what that means. I'm going to poker face, try like, well, what do you think? What do you think that might mean? Okay. What else maybe, right? And try to get the kids to reason it out without you rescuing them from thinking. It's
Do you
hard.
have a discussion with them, Alice, or
I'm sorry, Kristen, what?
do you have that discussion with them with that problem?
You bet. You bet. I would start this lesson by asking them to, well, let's say I'm doing this math problem. I would want to start this with them reasoning through it, breaking it down. What do you think it means? Let's visualize it. What can we figure out, even if we don't know how to do it, prior to me giving them the equation? I mean, I would rather do this whole entire lesson where they explore distance, rate, and time a variety of ways. It might be in Desmos, where there's a really great activity in Desmos with a turtle crossing the street, and there's a graph of the time versus the distance. That's a really great activity that helps them explore and understand the relationship on the graph. Again, without telling them what do these elements of the graph mean, and it is related to this. So I might do it in Desmos. I want them to, in some way, explore distance and time and what happens. That I ask them to create scenarios. What do you notice? How would you figure out when you have, here's two cars and they're going in opposite directions? How would I have them construct and think about how to do this, and how could they derive the equations? That's really the holy grail. The holy grail is the kids derive the equations. And that is one of the 8 mathematical practices is through pattern finding, they find the formulas instead of, I tell you the formula and you use it. What, you don't know this? I told it to you like 50 times. You know what? No one knows this. And so that doesn't work. And so I always tell my students, it's a waste of time to memorize formulas. You're going to forget it. You have to be able to derive it. Do you understand the situation that you could figure out the equation, the formula, or at least a way to solve it even without the algebraic equation? All right, so see, is that was none unless I ask them to figure it out before I tell them how to do it. I really love a low floor, high ceiling question. A low floor, high ceiling question would allow any student to approach the problem, which, I mean, this could, in a sense, that I could ask students to just think about going distances apart, right? If you were to go this way, what do you think would happen? If you were to go in opposite directions, what math would you use? Where I'm not necessarily asking them, if I just take off the how long until they're 90 miles apart, just take that part off. This is what Annie Fetter is amazing at. She takes off the question. So you take the math problem, but the part that says, how much money would they have? How long? At what time? What's the value of? Just take that off. Give the whole problem minus the question, the actual question, get rid of it. And then you have the students, well, what questions could you ask? That's the game changer right there. With this information, what could you figure out? I think you'll see a lot of Dan Meyer in his 3-act math doing a lot of this type of approach. What could you figure out? What do you want to figure out? What do you wonder? Exactly, Gabby. So a low floor, high ceiling question would allow any student to approach the question, even at a basic level, but even your advanced students could take it much, much farther. So here is what I hope is a low floor, high ceiling question that I asked my students on Friday. This is what we did. So what happens, I woke up and my 9-year-old, who watches way too much YouTube videos, and I have a feeling that this is from Mr. Beast, the YouTuber. He's like, hey, mom, if you were to get $1 million to eat at all of the In-N-Out burgers in the world, and you got to buy something from each one. You got to go in and you got to buy something from each of them. If they gave you $1 million, would you do it? Well, I have a lot of questions about this before I'd say whether or not I would do it. Great. What are these questions? So I want the students to do a combination. Just tell me things. Just keep going. Write down 50 things about this. What are things you notice? $1 million is a lot of money. Is it? Is $1 million a lot of money? How much money do you need to retire? I like to think about this math problem being like if you gave a mouse a cookie. Now, Gabby, I don't know if you have seen this book. Have you seen this book, If You Give a Mouse a Cookie? So it's a children's book, for like 3-year-olds. And has cute pictures. And it says, if you give a mouse a cookie, he's going to ask for a glass of milk. Well, if you give him a glass of milk, he's going to want a straw. Well, if you give him a straw, and this whole story keeps going like this, if you give him a straw, he's going to drink the milk, and then he's going to need to take a nap. But if he needs to take a nap, he needs a cozy place to sleep. If he needs a cozy place to sleep, then he's going to need to have a pillow. Well, if he needs to have a pillow, the pillow's too big, and I'm going to have to make the pillow smaller. I don't even remember what this story is. Now I'm just making it up. I know it's if you give a mouse a cookie, he's going to need some milk. And then after that, I forget. But it then comes full circle to, well, if you need this, then he's going to need a cookie. And you start the whole cycle all over again. So I feel like a good question is like, if you give a mouse a cookie, well, do I have to travel to all these places? If you had to travel to all these places, what would you need? Do I need a hotel? Do you need a hotel? Could you get to all of the In-N-Out burgers in one day? You know what? That begs 1,000 questions all by itself. Could I get to all the In-N-Out? How long would it take me to get to all of the In-N-Out burgers? How many In-N-Out burgers are there? That's a good question. How many In-N-Out burgers are there? And I have a solid rule, you guys. I have a solid rule. And that solid rule is do not tell students things they can look up. So in addition to doing this as my warm-up, because in this particular activity, I just wanted them to ask a lot of questions. Like ask me a lot. We're not going to figure out anything. We're going to ask a lot of questions. Be curious. What do you notice? What do you wonder? What would you need to know to do this? This is just really a very big question. At a basic level, I just want to know, if I have to pay for it, would I have enough money at all the In-N-Out burgers? Say low floor, right? Is $1 million enough money? But do I have to pay for my travel? What kind of travel? Do I need to fly? So just so you know, there's 358 In-N-Out burgers. I didn't look that up. So one of the students told me that. Like, you have to buy something? Yeah, you got to buy something. What's the cheapest thing on the menu? Oh, can I have water? All my classes ask that. Can we order water? Like, it says you have to buy something. They give you water, so I think that would not count. But even if you just got water, how long does it take you to wait in line? I mean, people really like In-N-Out burger. There's probably going to be a line. How about we go to each, when you look up restaurants on Google, it shows you this little graph of the average wait time at a particular hour. Do you see how I just made this math problem really hard? Okay, if I were to plan out going to all 385, if I were to plan out going to all 385 In-N-Out burgers, I would do the first one in the morning. It would probably only take me, wait, I can't go in the morning. They're not open for breakfast. So I have to just hang out all day at an In-N-Out Burger. Or maybe that's when I'm traveling and I have somebody, I pay somebody to drive me in a car so I can sleep in the car and not have to go to a hotel. Do you see how this is like giving a mouse a cookie? I can make this problem incredibly complicated. How much gas am I going to spend? How much do I have to pay this dude to drive me? Or do I need to stay in a hotel? How do I plan it so I get there when they open and I'm traveling to the next state? There's 7 states, by the way. In-N-Out Burger is in 7 states, and there are 4 In-N-Out Burgers just in my town, Fresno. But on average, if I wanted to do this in 92 days, why do it in 92 days? One of my students said that's as long as they'd be willing to eat In-N-Out Burger. Okay, cool. So what you're going to do is you're going to make up your own rules, because in order to answer this question, you're like, all right, I need to do this in a month, or I just would miss my family. I'm willing to do 92 days. Okay, so in 92 days, you'd have to go to, or 70, whatever number she said, 72 days, 62, she said something. In order to do it in that many days, you'd have to go to 6 point something In-N-Out Burgers every day. All right, well, there's 4 In-N-Out Burgers in Fresno, so I could get to all 4 of those in one day. That part's easy. But then I'd have to get to 2 more in the same day. So is there 2 more that's close enough to the 4 In-N-Out Burgers in Fresno in order for me to get to all 6? So you'll notice in this whole ask a question, we are doing some math. But I didn't write the math questions. The trick here is you have to know, in real life, you have to know what questions to ask. No one gives you math problems. You give yourself math problems, and you have to know how to solve them. And it could be complicated or it could be easy. This question actually is really interesting because I talk about it being something. If you think about getting your math problems from YouTubers, I was watching a preview of a video where they filled up their mansion on the beach with packing peanuts. You know, these little, in a box, when you mail a box, it comes with these little tiny styrofoam packing so it doesn't break. Gabby, you know what I'm talking about? Yeah. They filled up the whole mansion with packing peanuts so they could jump off the 2nd floor into the 1st floor into a swimming pool of packing peanuts in the living room. How many packing peanuts would you have to order? How much would that cost? How many packing peanuts do I need so that when I jump off the top of the 2nd story, off the top of the stairs, I don't die as I dive into these packing peanuts? Well, at what force would I hit the peanuts that they would compress so I don't hit the floor? Do you see how I could make this a calculus problem? Or 3rd graders could do this. If you show kids a YouTuber video, you know, these idiots who do dumb challenges, you know what I'm talking about. This is a plethora of great math problems. Will you get enough views from this video to pay for all of those packing peanuts? And this actually got brought up during my thing. When you're going to all of the In-N-Out Burgers, you're going to film it and put it on YouTube. I'm like, okay. Would you make enough to make this worth it? How many views? Could you just start a YouTube video tomorrow, a channel? Could you start a YouTube channel tomorrow and make money going around to all of the In-N-Out Burgers? And actually the answer is no, because you have to have 4,000 watch hours. That's not 4,000 views, it's hours. So it's how much time they've watched it. And you need to have 10,000 subscribers. And those 4,000 watch hours you make no money on. Those 10,000 subscribers you make no money on. It's the 4,001 hour that you make money on. So that's X minus 4,000, just so you know, get some algebra in there before you even start to earn money. Now we're having a whole entrepreneurship lesson out of this. how to be a YouTuber. Low floor, high ceiling. It's not just answer the question and everyone gets the same answer. It's what question are you going to answer? And it can be as complex as you want. Now, this is a question that I did with my students, and we did it in Jamboard. I said, what would be, and I did on paper. I did both. I gave them a choice. So on UCubed, it's all PDFs that you can print out.
Yep. Where is this from?
Cubed.org. I got the little logo in the corner.
Okay, cool.
So they have a ton of math problems on there. They're really great. They're creative, they're visual, they're collaborative. Most of their stuff uses all 4 C's. And the directions on this particular activity said, don't answer the kids' questions. Said, don't do it. The directions tell the teacher, don't answer the kids' questions. If the kids ask you a question, you have to answer their question with a question. Now, the directions on here technically give you all the information you need. So UCubed is famous for this, where I read the question and I'm thinking, this isn't enough directions, and I want to give more directions to the students. Almost all the time, I want to give more directions. I want to be more clear about what I want. Math's not about what I want. That's not what math is. Math's creative, math is visual. Math is thinking, got to think about it. How often in life are the directions that you have to figure out clear? No, they're not. When I need to put together a desk that I ordered off of Amazon or IKEA or wherever, and how often are you like, what the hell are these directions saying? Like, which screw am I supposed to put in here? They all look on the picture, they look like this, but here they look like they're the same screw. How do I know which screw I'm using? How many times has that happened to you? All the time? I got somebody, one of our members, her boss wants her to create class rosters, but then has all of these rules. Like it has to be equally balanced with boys and girls. It has to be equally balanced with kids from grade levels. It has to, every way that you can break down different things has to be equally represented. Her and I have already spent a couple hours like thinking of ways we might do this. Like it's an impossible task. Like what? Make this person do it. They didn't, make it all evenly balanced in every way you possibly can. Yeah, I'd like to see you do that. I'd like to see you do that. That would be awesome. So life gives you very challenging questions where you're like, I'm not really sure what I'm supposed to be doing here. How do I do that? That's life. All right. So the questions that we give our students really should have some level of ambiguity, that it's not so clear. They know how to answer it. I know what to do. Right? Let's back this up. This is not ambiguous. There's no like, I'm not sure what it's asking. No, you're sure what it's asking. You know what it's asking. You just don't know how to do it. How long does it take? You get the question. You know what you're supposed to get. It's not ambiguous. You just don't know how to do it. That's a big difference. I'm not talking about I don't have the skills. I'm talking about like, what? Let me read that again. Attend to precision, mathematical practice number 6. This says, if you read it carefully enough, it says what you need to do very concisely and precisely. But I have to read this really clear, and I'm probably going to do it wrong the first time, and then I read it again. I'm like, oh, wait, I'm supposed to do this, and I correct myself. So I had students working in groups. They were working in groups to do this problem, and almost every single group thought that they would put $1 of pennies in each. So they're like, 100 doesn't divide by 3. 100 doesn't divide by 3. Do you think you might be misreading what it says? No, the only one that divides is the 5. Okay. The only one that divides is the 5. So maybe you're not supposed to do it that way. You are supposed to do $1 and divide it up evenly with each cluster of circles. And in each cluster of circles, they have to have the same. There's another page that's not included on here with a few more rules. Like on this one that has 6 circles, I can put however many coins in a stack, but all 6 stacks have to have the same amount. Over here in the stack of 5, every stack has to have the same amount, but it doesn't necessarily have to have the same amount as the stacks of 6 in the 6. What does that mean? Okay, good. Why don't you think about that? And that'd be the point, right? Math class should be, why don't you think about that? My students really struggled with this, but at the end of class, one of my students who is always disengaged, she does nothing. She normally ditches, she doesn't come, and she says, can we keep working on this tomorrow? Well, I wasn't going to, but we are now. Like, thinking is engaging. When you like, it's not about you being dumb and you don't know how to do it. On this question, you just feel dumb. You're supposed to know what to do, and you don't know how to do it. You're dumb. This question, you're not supposed to know what to do. You're supposed to think about it. You're supposed to get it wrong. You're supposed to regroup. You're supposed to talk about it with your group members. What do you think we should do? A good math problem should require that you lean in. What do you think we're supposed to do? To me, that's a good math problem. It's not what are we supposed to do? It's what do you think? This is what I was thinking, that it forces a good math problem should require some level of collaboration and discussion to figure it out. That's to me a good math problem. So which C's does this have?
All of them?
All of them. It has literally all of them. And there's more than one right answer. There's more than one solution.
Did you let the students use real pennies?
Kind of. I don't have stacks of pennies, so ideally yes, but no. In the Jamboard, I had 100 pennies for them to drag.
Oh, that's cool.
In real life, I had some foam circles.
What about bingo chips or something?
And it was the same activity, digital or paper, which gets me back to, to this point. Digital is different and paper is different. I did both. I did it digitally or paper, same thing, but it wasn't a regular math problem. It wasn't a 1921 math problem. It was a 2021 math problem. I let the kids choose. What do you want to do? Some of them we busted out big butcher paper. I have learned that I get a big giant sheet of paper, from the paper rolls in the library. You know what I'm talking about, Gabby? So that paper you put on your walls of your classroom, I just put a big piece of that at each of the tables. I have tables in my classroom because when I come around, students ask me questions, I just write on we just use as a big giant piece of scratch paper. And they doodle on it. They like to do that. Keeps them from drawing on my desk too. But I just have a big giant piece of butcher paper on the desk all the time. And I don't necessarily change it every day. When it's like filled up, I just get another one or we turn it over. So I want a math problem that they just, I don't know, let me think about it. It's not that you're dumb, you have to think about it. That's what I love about open middle questions is you're not allowed to get it right the first time. It takes several iterations. And for a math problem that seems really simple, like 3 + 2 × 5 + 2 squared, instead of asking what's the answer, I'm like, what's 2 ways to do it? And graspable math is really great for this. So I'm going to insert a math expression. This is 3 plus 2 times 5 plus 2 squared. 3 plus 2 times 5 plus 2 squared. What you're able to do in graspable math is grab it and drag it. So now I have two of them because we're going to do it two ways. So what I tell the students is we always do it two ways. What do you do first? Parentheses. Why do you do parentheses first? Because my teacher told me. That's right, because my teacher told me, not because it makes sense. No, how about we do the 3 and the 2 first? Graspable math won't let me. Notice that it was like, I don't think so. No, can't do that. Graspable math won't let me do it wrong. So graspable math lets me, can I distribute? What just happened? What just happened? Explain this to me. See what I'm talking about? Communicate. Communicate is not show your work. It's explaining. I'm using the commutative property. They don't know that word. I literally, when I was in college, after I took my third year of calculus, I took a math proofs class, and that's when I finally got the commutative and the associative property. Like, I'm good with those vocabulary words. That 2 times 3 is the same as 3 times 2. So communicating doesn't necessarily have to be using the right vocabulary, but it's at least understand. I mean, everyone knows that 3 times 2 is 2 times 3. All the students know the commutative property. They might just not know the vocabulary word. All right, well, can we do the exponents first? Can we do the exponents first? What? No, you can't. Because if this was x plus 6 squared, don't we literally ask students to do this when we take Algebra 1? Isn't this an Algebra 1 math problem? What's the difference between x plus 6 squared and 3 plus 6 squared? What's the difference? We literally don't compare and contrast. But what would be the purpose of doing this if we don't build number sense towards the numbers we actually use? Because nobody's gonna do x plus 6 squared. Nobody's gonna do that. So not a life skill. So if it's not building number sense, why bother teaching it? Notice that when I do the x plus 6, it's x plus 6 times x plus 6, and then I end up getting x squared plus 12x plus 36, right? Well, I can do that with numbers. Now I can distribute the 2. I think it'd be easier to add the 50 and the 40 first. Then I'll add the 3 and the 8. And then I'll add the 11, right? Explain what you did. Why did that work? What's another way to do it? Okay, I could add first. Got the same answer. Is there another way I could have done it? Let me grab this, pull it down here. Try it again. Oops. And pull the 3 over on this side. Does that change it? What does it matter if the 3 is on either side? I want students to be able to write equivalent expressions in a way that's easier. Sometimes it's easier. I was showing my son he's 9. So I'm like 36 times 4. What I love is he didn't cry. This didn't even bother him. He's 9. He's like, all right, well, I'm going to make 36 circles. There he goes. He's making 36 circles, and he's putting 4 in each circle. Why did 36 times 4 not bother him when he doesn't know how to do it? Because he understands the concept. He doesn't do the algorithm, but he's able to derive and figure out how to do 36 times 4 because he understands the concept. All kids should approach math with confidence on a math problem they don't know. I don't know how to do it, but I understand the concept, so I should be able to do this. One of my favorite math problems is when I gave my 11-year-olds a calculus problem. Someone had put on Twitter, hey, my students had a really interesting conversation about this math problem. Hold on, I got it here. I have the math problem. It's this one. Is it this one? Yeah. A rectangle whose length and width are 10 and 6 respectively is shown below. The rectangle is continuously rotated around a straight line to form an object whose volume is 150 pi. Which line could it be rotated around? This is a DOK1 math problem. Which C does this have? None of them. But it's calculus, so it's hard. I gave it to an 11-year-old. You guys, I answered a question with a question. Here's how this went down. I required they take a selfie. How do you feel about this? There's the 11-year-old, there's their selfie. That's how they feel about this math problem. Say, all right, well, the first thing we do is we just make observations. What do you notice? Rectangle, 6 and 10, length and width, small sides, big sides, rotate, 150. Weird symbol, 4 answers. She thinks she's annoying me. She's wrong. I think this is awesome. Keep going. 1 answer is correct, 3 are not. Math, I don't understand. I shouldn't be doing this in the first place. I told her, I don't think you'll get it, but I just want to see what you can do. So she's really mad. And she's like, well, I got 20 slides. I'm done. I said, no, you should have at least 20 slides, but there's rules here. You have to take a selfie. Show me your confidence level. You need a brain dump. Everything you think about this. What do you notice? What do you wonder? What do you notice? Just keep going. You got to give me like a lot of things. Keep going. What else do you notice? What I love about slides is that it's only allowed to be one thing per slide. And that way they can present their ideas. What were you thinking? They can communicate what they were thinking. I'm like, well, okay, well, here's the next rule. You are required to Google search something. You can't tell me I don't know until you look something up. So she does some Google searches. She's like, I still don't get it. You have to have a minimum of 3 selfies. So here's number 2. The selfie can be a thumb selfie. They can draw it. They can put an emoji. I don't care. All right, well, let's go back to the question. And you'll notice what I did here is I took out the question. Let me look at the original problem. Here's the original problem. Okay. So let's just take out the question. Find the perimeter, find the area. Excuse me. You'll see down there, I said, what could you figure out? Don't worry about what the question's asking you to do. What could you figure out? She says, I could find the area and the perimeter. I'm like, awesome. Let's do that. So she figures out the area. She figures out the perimeter. She's like, I still don't know what the question is. So we go back to the original question. She says, what does continuously rotate around a straight line mean? I said, that's a good question. You should Google that. Because you remember, I'm not going to tell you something that you can look up, even if you're 11. Even if you're 11 doing a calculus problem, I'm not going to tell you something that you can look up. So she finds this, and you guys like, whoa. I wrote this for her. Whoa. If I rotate a rectangle around a straight line, it will make a cylinder. Okay. 2 seconds ago, why do I have to do this? And now we are at, whoa, I'm leaning in. I'm kind of interested now. You know why? Because thinking is interesting. When you do your own thinking, when you have to figure it out, when you have to earn it, it's interesting. Not interesting at first, but eventually. All right, we have a rule, you have to collaborate. So you have to talk about it with somebody else. You have to. So she asked another student. And so the other student looked at the screenshot and said, well, I'd look up the volume. Well, how do I find the volume of a cylinder? How do you find the volume of a cylinder? You guys, so far, I've literally done this, just been sassy. Like, that's a good question. How would you find the volume of a cylinder? So she's got these pictures off the internet. Sounds good. Thanks for that. And then she found a calculator that finds the volume of a cylinder. I like that. Good using your resources. Thanks. So then she said, well, what's the radius? I think my radius is 33 because that's what the perimeter was. Oh my gosh, you guys, for reals, my heart is full. My heart is full. I mean, like, it's wrong. But she used the word because. That's all I want. That's all I want. So that's all I did. I just waved an index card. I took a picture of me waving the index card. And she's like, oh, the radius is 10. I swear to you, I'm not doing anything. All right, so the radius is 10, the height is 6. She's got this calculator. She puts it in the calculator. She figures out that says that this is the volume. She's like, I don't think it's right because, wait. Because again, because that sounds amazing. Okay, I don't think I did this right because the volume's supposed to be 150. Now it's 150 pi. Forget about that. Let's remember she's 11 and it's a calculus problem. Doesn't matter. She's given herself feedback and she's going to try again. I've already won, you guys. I've already won. You know, I give her a little feedback here. It's supposed to be 150 pi, but whatever. And then she had this epiphany that the question's not asking for the volume, but what side it's being rotated. So she rotated the shorter side and that did not work. This person's 11. And rotating in the longer side didn't get me 150. So what if I did it through the middle? Okay, now we've run out of time. The bell is rung. It's time to go. I said, you know what, girl? As far as I'm concerned, she solved it. That's the right answer, by the way. She's 11 and she figured out this calculus problem. She figured it out because I didn't help her. I did not rescue her from thinking. Let's go back to all the attitude that we had. We'll start with our initial selfie. Rectangle, 6 and 10, length and width, small size, big size, rotate, weird symbol, 4 answers, 1 answer is correct, 3 answers not. Math, I don't understand. So she started out like, why am I doing this? This is dumb. It's calculus. I shouldn't be able to do this. And she figured it out. And you know what? At one point in this, I swear to you, there was a fist bump. She didn't want me to see it, but I saw it. Because figuring things, it feels good to earn it. Feels good to earn it. We steal the fist pumps from students. We steal the fist pumps by giving them too much information. I gave you what you needed to know, but you had to think about it. And you got it wrong. And you had to think about it some more. And you had to talk about it with your neighbor. And you had to think about it some more. And then when you figured it out, that felt good. That felt good. All right. So in summary, have at least one C. Have at least one C. Thank you. Questions? Okay, I'm going to stop the recording.